are going to learn another hypothesis testing test, which is a chi-square test. So t-test, which is also used for testing the hypothesis, and this is other statistical test which is used for hypothesis testing. And when we use the t-test and when we use chi-square test, that we have to understand first, for data which is continuous data, like height of the individuals or weight of the individuals. In such case, in that scenario, we have to use the t-test. For categorical data or frequency data, for example, data like for for data like phenotypic ratio of the plants, for example, in Mendelian cross, how many round plants or round seed containing plants, and how many smooth seed containing plants, or how many red color plants and how many white color plants. So such categorical data or frequency data is present. So in such case, we have to use the chi-square test to test the hypothesis. For example, when two means are there, if it is a continuous data, we check the difference between the mean. The difference between the means of two groups is because of the is because by chance, or it is really by the biological factor. For example, two groups are there with which are exposed to drug A, which are exposed to without drug and drug A. For example, drug A. So when there is a mean difference, so when we see that to p value 0.05, our calculated t value is just less than 0.05, then we make a statement, or we make a conclusion that okay, so the chance of getting such variation between the two means is very small. When such a that means by getting such variation by randomly or by chance is small. So when the possibility is very less to get by chance, so we reject null hypothesis, which states that there is no difference between the two groups. Then we automatically supports the alternative hypothesis. Similarly, in chi-square test also, there we see the null hypothesis and alternative hypothesis, which one supports our data. So in a chi-square test, there we actually compare our observed results with the expected results. Even we know when we cross a tall plant with a dwarf plant, so we know that in F1 generation we get to 3:1 ratio plants. So suppose 100 plants are there, so 75 plants are 75 plants are tall and 25 plants are dwarf. In such case, when we have a data where suppose that 76 plants are tall and 24 are dwarf, so we have a categorical data. So when we have such categorical data and we have expected frequency, observed frequencies, and these observed frequencies are not similar to the that no expected frequencies. The expected value is 75 and observed value is 76, and expected value is 25 and observed value is 24. So when we have such kind of data, so we see whether there is a difference. So okay, in such case, we have two hypothesis. One is null hypothesis, other one is alternative hypothesis. Null hypothesis says that there is no difference between the observed frequencies, and there is no difference between the observed frequency and the expected frequency, and the difference which is there, that is 75 76, that the one difference is by chance. So when we get a chi-square value which is less than 0.05, so though when there is a difference between the observed and expected one, so that difference we say that no, it is the possibility of coming by chance is very less. So by chance coming such a value is very less. So then we say that okay, the difference is really a difference. So when we say that difference is really a difference, that means we reject the null hypothesis and support the alternative hypothesis. So null hypothesis, where we say that no, when the mean differences when the observed and frequency and expected frequency is there, difference is there, so such difference is really by chance, or is really by experimental factor. So when we calculate this chi-square value for such data, So we get a chi-square value. So suppose that chi-square value is less than the 0.05, that means suppose 0.02. So such type of difference of events, that is a 75 76, that one difference coming by chance is we say just a 2% or 3%. When that comes by just a 2% 3% of chance, that means 90 70 to 90 80%, that is just because of the biological factor. So such biological factor is really making a difference between these two, the difference between the difference between the expected value and the observed value. So this is how we calculate. So the formula for chi-square is the chi-square equal to some observed and expected frequencies whole square by expected frequencies. So this is the formula for this one. And we know that no chi-square, similarly it is like a t test only, where we test the hypothesis, so null hypothesis and alternative hypothesis. But chi-square, where this is used for data which has categories and frequencies, and whereas that no t-test which is used for the continuous data. Thank you for watching this video.